chiller. Now the expansion valve is located between the condenser and the evaporator, and in this version it is located just here. So in this video we're going to look at the three most common types of expansion valves in typical modern chillers, that being the pilot operated thermal expansion valve, the thermal expansion valve, and also the electronics expansion valve. But first, what does an expansion valve do? Well, the expansion valve controls how much refrigerant flows between the condenser and the evaporator. The valve responds to the suction line superheat which is entering the compressor. This is the suction line here going into the compressor, and it will vary the amount of refrigerant flowing into this to suit the change in the cooling load. So the evaporator needs to have a certain amount of liquid refrigerant in it for the heat exchange to occur, or for sufficient heat exchange to occur. If there's a lot of superheat coming from the evaporator, then that means there's a lot of vapor in there, and that means there's not enough liquid refrigerant in the evaporator, so more needs to enter. So the expansion valve is keeping that balance between the right amount of liquid refrigerant and the right amount of superheat. You only want vapor entering into the compressor. If liquid gets in there, too much liquid, it will break the compressor. The compressor does not like liquid entering it. So keeping the right amount of superheat entering the compressor keeps your compressor and your chiller healthy, and also allows it to run in a much more efficient manner. So the first expansion valve we're going to look at is the pilot operated thermal expansion valve. In the real world, the pilot operated thermal expansion valve looks something like this. Here we've got the pilot expansion valve located just here, and over here we've got the main thermal expansion valve. Now the refrigerant will flow from the condenser. This is the condenser here, and the refrigerant will flow into this. This is a king valve, just so you can isolate it and you can lock that off. So it will flow through this valve, up through this tube and into the base of the main expansion valve, and then up into the evaporator. To control this flow, we've got the pilot operated thermal expansion valve, and that is also fed refrigerant from the base of the condenser. This flows through this tube here into the valve. The valve decides if it can flow in or not. That flows through into the base of this, the main expansion valve, and this flow is what controls the main valve. Attached to the pilot expansion valve is this capillary tube. This rides up and attaches up into a thermal bulb which is placed on the suction line of the compressor. So just to give you a side view there of how it's all connected. So we've got the pilot valve located down here with the connection going to the condenser, and that flowing through into the base of the main expansion valve. We've also got the capillary tube which rides up here into the thermal bulb which is attached to the suction line just before the compressor. And then the main refrigerant flow will pass through here, through this pipe, into the main valve. This expansion valve decides if it's allowed to pass or not, and if it is, then the refrigerant will flow into the evaporator. So the thermal bulb will be located on the on the suction line, and it looks a bit like this, with the capillary tube running along here. Now this thermal bulb is filled with a refrigerant. When the superheat increases, this starts to cause a heat transfer across into the bulb. Usually this is covered with an insulation. You can see here I've just cut the insulation open so you can see it. It's important I replaced it back afterwards. But the superheat will transfer its thermal energy into this bulb. The bulb is filled with the refrigerant, and that refrigerant starts to boil and expand. As that expands, it pushes refrigerant out through the capillary tube, and that causes a pressure increase in the capillary tube, and that pressure pushes all the way along the capillary tube, all the way down through it and into the top of the pilot valve. So that pressure is pushing down onto the top of the valve, and with that you can now control the valve depending on the level of superheat. So we can look at a section view here. So we've got the condenser on the side, the evaporator located above. We've got the capillary tube running up and connecting onto the suction line. Down the bottom we've got the pilot expansion valve. This is connected through with a liquid line going to the main expansion valve. Inside there is a piston body and spring. This piston body and spring is what will control and allow this refrigerant to flow through into the evaporator. So as the pressure increases in the capillary tube and it starts to build up and push down on this valve, you can see inside the valve there is a diaphragm which is connected to some push rods and then onto this valve head, which is also spring loaded. There are a few variants of this design, but this is probably the simplest and one of the most common used. So as that pressure increases and starts to push down on that diaphragm pushes against the piston rods, and these rods push the valve head down, and that causes a slight gap to form there, and this allows refrigerant to start flowing out. So the refrigerant is starting to flow from the condenser through here and into the pilot valve, and then that is going to start to flow through into the liquid line. As that refrigerant starts to fill the liquid line, it starts to build up some pressure and starts pushing against this piston housing here. That pressure is going to lift the piston off its seat, and that's going to allow the main refrigerant in the condenser to start to flow through this valve. When the bulb detects the maximum allowable superheat, it's at full pressure now. The refrigerant inside is fully expanded, and that's pushed down the pin rods inside the expansion valve all the way down to the maximum amount of refrigerant from the condenser is now flowing into this through the line, and has pushed the piston body completely off its seat, and that is allowing the maximum amount of refrigerant to flow into the evaporator from the condenser. The next expansion valve we're going to look at is the thermal expansion valve. In the real world, the thermal expansion valve looks something just like this. So this one is actually on an air-cooled chiller, but it's still got the flow of refrigerant coming through and then going off into the evaporator, and you've also got the equalizer valve coming through there, and attached to the top of the thermal valve is the capillary tube which goes off and measures the superheat. Now these type of valves are usually found on smaller chillers. As they start to get larger, that's when they move over to the pilot operated valve to give much better control. So the thermal expansion valve is very similar to the pilot operated one, except that it hasn't got the main expansion valve there. The thermal expansion valve is the main valve in this type. So again, we've got the capillary tube rising up and connecting onto the suction line to measure the superheat, and we've got the refrigerant in the condenser which will flow through, is being held back currently by the valve head, and once released that will flow then off into the evaporator. So the pressure is starting to build in the capillary tube due to the superheat transferring its thermal energy over into the thermal bulb and expanding that refrigerant. That pressure increasing and pushing down the diaphragm, which pushes down on the pins and starts to knock the valve body off of its position, allowing some refrigerant to start flowing from the condenser and into the main valve. That refrigerant then starts to flow and goes off into the evaporator. And finally, once the maximum amount of allowable superheat is there, the valve body opens fully, allowing the maximum amount of refrigerant to flow from the condenser and through into the evaporator. So this type of expansion valve is exactly how you would find in a kind of a household air conditioning unit, but the valve is just a slightly bigger version, obviously to handle the load, the cooling load which it needs to for the size of the chiller. The third expansion valve we're going to look at in this video is the electronic expansion valve. Now in the real world, the electronic expansion valve will look like this. You can see it highlighted in the circle here. Now this type of expansion valve gives the best performance, and that's because the valve here actually uses a stepper motor in the body, and that precisely controls the positioning of the valve body inside, allowing a very accurate and precise flow of refrigerant. So the electronic expansion valve, I've just illustrated that here. So we've got the main shaft connected to the valve head inside the body there. Then behind that we've got the stepper motor, and that is connected to a controller. The controller measures the temperature and pressure from the evaporator outlet, and this allows the superheat to be calculated and that value to be determined. The controller decides is there enough superheat or not, and then sends a signal to the stepper motor to very precisely control this shaft and the valve head to move that back to allow and adjust the refrigerant flow rate. So that refrigerant in the condenser flows along the liquid line into the base of the motor, or the valve, sorry. The controller is sensing that more refrigerant is required in the evaporator, so that sends the signal to the stepper motor just to pull that valve head back slightly and allow some refrigerant to start flowing. That refrigerant then flows off into the evaporator, and then at the maximum demands, the stepper motor has been moved and rotated the complete rotation.